All right, guys, this is another opportunity for you to see how to do a problem that involves GCF and LCM, a real world problem. So I'm going to read it to you first, then we'll break it down. Audra has 2 rolls of streamers to use in decorating the school gym for a pep rally. The red streamers are 64 yards long and the blue streamers are 72 yards long. We want to know what the maximum length each streamer can be so that they are all of equal length. And we want to know how many red streamers she will have and how many blue streamers she will have. So first I'm going to start by highlighting my problem. We know she's got red streamers, okay, and they are 64 yards long. We also know that she's got some blue streamers and they are 72 yards long. And we know that we want the question of the hour here is, what is the maximum length each streamer can be so that they're all of equal length? We're going to start there. Okay, there's lots of other questions that are down below, but we're going to start there. So in doing that, first I'm going to start off knowing that this is going to be either a GCF or LCM problem. We want to look for the key word, the one that makes the most sense here. And since it says maximum length, that's our key word right here. That maximum length each streamer can be, that means that we are really looking for the GCF, the greatest. That's your maximum. Okay, and to find the greatest common factor, we typically will use, or I've been typically using, the sled method. You can use either method, the list or the sled. I happen to like the sled. I think it's a little simpler. So I'm going to take those two numbers, 64 and 72, and I'm going to put them on a sled. Okay, then what we're going to do is we're going to look for common factors. And if you look at these two numbers, the number 8 is probably jumping out at you. So 8 is the common factor. When I divide those two numbers by 8, 64 divided by 8 is 8, and 72 divided by 8 is 9. Now I want to look at the two resulting numbers. 8 and 9 share no common factor other than 1, so we know that we don't have any more division to do here. Then we just have to understand what GCF is. So remember that GCF is on the left. If you know your left from your right, this should make this pretty simple. So we know then that the GCF is going to be this guy right over here because it's the only factor we pulled out on the left. So the GCF will equal 8. Now let's talk about what that means for the solution to this problem. It asks us what the maximum length of each streamer can be. So each streamer can be 8 yards long. And I know it's yards because that's the units they used in the problem. All right, now the next question was, how many red streamers can we have? All right, well, if I have a grand total of, in red, 64 yards of red. So if I take the total yards of red I have, the 64, and I divide it up into 8-yard groups, because that's how long each streamer will be, I'm going to find that I get 8 red streamers. And if I take the blue streamer and I divide it up, the 72 yards that I have of the blue, and I divide it up by the 8 yards each streamer is going to be, I'll find that I have 9 blue streamers. And that answers all 3 questions. Notice, by the way, right here, this is the 64, this is our red, and this is our blue. And if you notice, when we divide here, if I divide 64 by the 8 yards per, I'm left with 8 pieces. If I take the blue, the 72 yards, and I divide it by 8, I get 9 pieces. All right, here's question number 2. 2 airport shuttle trains leave the main station at the same time. Shuttle A returns to the station every 8 minutes. Shuttle B returns to the station every 10 minutes. In how many minutes will shuttles A and B leave the station together for the second time? First thing we need to do is identify some of the things we know and determine if this is going to be an LCM or a GCF problem. Well, GCF problems tend to be about grouping things. LCM problems oftentimes are about repetitive actions. So if you look here, and it specifically says that shuttle A, let me just get that in there, shuttle A returns to the station every 8 minutes. And it says that shuttle B, so let's get that in there, shuttle B returns to the station every 10 minutes. Those are things that are happening repeatedly. And remember, when we're doing multiples, it's repetitive addition. 8, 16, 24, those kinds of things. So we are now knowing, based on what we know here, we are knowing that we are going to be finding the the LCM, the least common multiple. So the LCM. All right, and we're looking for, we can do this a couple ways. I'm actually going to use the list method for this one because I want you to see what is going on here. So we're going to use the list, not the sled, although we could use either one. And typically I'd probably use the sled, but I want you to see what's happening. So this is going to be shuttle A. Shuttle A is going to leave the station, and 8 minutes later it's going to be back. Then it's going to be back at 16 minutes, and 24, and 32. And 40. And we know that because this is 8 times 1. And this is 8 times 2. And this is 8 times 3. 8 times 4. 8 times 5. That's how we get multiples. All right, now we want to look at what's happening with train B or shuttle B. So shuttle B comes back in the station at minute 10, and then 20, and then 30. And then 40, and then 50. So shuttle B, that's because this is 10 times 1, 10 times 2, 10 times 3, 10 times 4. That's how we get these multiples. All right, now look at these letters, LCM. So the L is least. The C is common. That means shared. What multiple do they share? And M is multiple. So what we've done is we've listed out a bunch of their multiples. Now we're looking for the one that they share in common. And if you notice, it's right here. 40 and 40 are the two numbers, the first two numbers that show up that they have in common. So it asked, in how many minutes will shuttles A and B leave the station again for the second time? In 40 minutes. Both shuttles will leave the station together. Make sure you guys have taken down these notes, and hopefully they'll help you get your work done today.